Hi, today working at Meadows, which is a fun little puzzle. Deceptively simple sounding, but quickly becomes pretty complicated. I'm going to start here with an easy 1-star puzzle just to get you familiar with the concepts and how we go about solving a puzzle and what the rules are. And the rules are, well, actually there's only one rule in Meadows, and that is that we need to slice up this grid into squares, and each square must contain one and only one circle. Part having the empty squares, each one's got to have a circle in it. Sounds simple. We haven't got any numbers to contend with, we haven't got any other shapes to contend with, we're only worried about squares or circles. It can quickly become quite complicated. To get started then, we'll look for some easy wins, some places where we know we can put some marks. We may not be able to draw squares straight away, but there are definitely some places where we can begin to draw squares. And one of those places is anywhere where we have two circles in adjacent squares, like here and then also down here. As we know that the squares we're drawing on this grid must contain one and only one circle, obviously we need to have a dividing line between those two circles that are adjacent. So although we may not be able to draw in a whole square yet, we know we can put in a line there and a line there like that, because we've got to keep those circles separated. The next place to look on a grid like this is to start from the edges, and then particularly the corners, and work inwards. And that's because these corners paint as constraints. We've effectively got two sides of a square here. We don't know how far the square will extend, but we know that we can't obviously go that way. That's the edge of the game. So we're using those constraints in our favour to help us work out where our squares must go. I'm going to start up in this corner because we've got a circle in that corner. It would be perfectly valid, and let me draw this in blue just to show you, it would be perfectly valid to have a single cell square like that with the circle in it. That could be a valid move, but first glance it looks like maybe that will work. We could then perhaps draw another square here to incorporate that circle, but then you can see the problem, and the problem is this square down here. There is no way we can incorporate that cell into a square and still have a circle in that square. We couldn't do this. For example, this isn't a square and we're encroaching on this blue square here. So there's no way to incorporate this cell into a square. So we know that actually this is not a valid solution. So what does that tell us? How does that help us knowing that? Well, it tells us that if we are working in from this corner that way and that way, we can continue until we reach a constraint. If we take this as the top right of our square, and we draw our square outwards, well, we can't go any further than this because we've now encountered this circle. So our square cannot be more than 2 cells wide. Well, we draw these squares, not rectangles. So if we're 2 cells wide, then we must also be 2 cells tall. So that will be our first square. I'm going to draw that in there in red as a permanent square. So that's our first square. We have a similar situation going on. If we carry on working this way across the board, we could take this as the edge of our square and come across here like this. In theory, we could come all the way across to there. However, this circle here is going to stop us, because if we come across 3 cells, then we're going to have to come down 3 cells. And if we come down 3 cells, then we're now incorporating the second circle, which is invalid. So this circle here tells us we cannot come across more than 2 cells horizontally. Come across there like that, and then we're here like that. Then we've got another square. To go 1 square bigger, we would have had to incorporate that second circle. And if we look in the other corner here, although we don't have a circle in this corner, we do have this circle here, and we know we already drawn in part of a square there. So we know that we're going to have to continue that line at least that far. And as we can't come down more than 2 cells in this direction, well, that's our edge. So again, we've got a 2 by 2 square here. It has to be that way. On small puzzles like this, would end up with a lot of 2 by 2 squares. They do tend to be quite common. But here in this gap, we've got 1, 2, 3, 4 cells across. Now, can we come down 1, 2, 3, 4? Yes, we can. And we know that we're going to have a line there. So we can draw him a square here. Generally, when we're playing this, we're looking to make the largest square we can, one incorporating a single circle. And now, pretty easy to see, given this circle here and the constraint of this existing line here, that we can come down and across here, closing off that circle. And it's also fairly pleasant to see that if we come across here and split into two, we've got another couple of 2x2 squares. Now we're going to work in from this corner, and we've got the same thing going on. We've got a constraint here in that we can work upwards 2 cells, but we can't go any higher than 2 cells because we've got more circles there. So again, it's very simple to see that that has to be a 2x2 square there. And the easiest way to split these two is where's a line down here, which we cut in half, giving us another couple of 2x2 squares. And working our way across, because we're using these existing lines as constraints, you can come further across in this direction because we could draw a 2x2 there. Then to incorporate this circle, we would need to make a 4x4, and that would be too large. So actually what we need to do is split this whole section into 2 squares like that, and that gets us a couple of 3x3s, each with 1 circle. I'll draw those in now. And again, we're using these pre-existing constraints and then the constraints of the next circles that we encounter to tell us where our wall must be, and it must be there. And then once we cut it into carry working across the board like this, we have an upper boundary and a right-hand boundary, and we've also got these boundaries that are built in. If we're working across the board this way, we can keep going until we encounter the next circles, which are these 2. So we're going to have to draw a line in here to split those from the other 3. And if we do that, then we can split like that, and that gives us 3 more. So now we've just got this area. Again, we're already constrained. We've got our quick constraint bottom and left, and we've got our existing boxes constraining us to the top of the right. We've got 2 circles, so we know we need 2 squares. So we just cut them in half like that. And that's it. We've solved the puzzle. All our squares are actual squares, not rectangles. Every square contains one and only one circle. So the puzzle is complete and correct. So once again, that's an easy puzzle, a good introduction to Meadows. Good puzzle, and I hope you enjoy them.
Hi, I'm Pete. Don't forget you can get our Puzzle Weekly magazine delivered to you every Monday, completely free. Visit the link to get your copy.